It is important to consider how the new machine or group of machines will fit into your current and future farming system. You need to consider regulatory limitations to land use changes, for example, native vegetation or cultural heritage protection. You need to also consider physical limitations such as existing buildings, roads and channels, and the potential limitations from future business expansion. When designing the whole farm plan, you should purchase systems that can adapt to potential changes to current farming systems, such as new crops and new cropping rotations.
Probably the most important thing is they do a lot of evaluating before they buy the machine. They've got the right one and they're putting it the right way in the paddock, and the plan is probably the most vital thing of the whole system. If you get it wrong, you can't go and trade it in because it's built to fit your paddock. And we had that issue to start with. They came out with a satellite image and a plan and laid all these irrigators out on the farm. And I asked one question, how's the paddock going to drain out? And they didn't have a clue. No, didn't have a clue. So if you're not putting the effort into planning it, you could go ahead then, put the irrigators in and just have a total disaster. So planning before any metal is even looked at is the most important part, and there's not really anyone out there doing that, and we were doing it anyway. Plenty of people designing layouts on fields, but no one the overall picture of a drainage and best agronomy practice. Quite frankly, you've got to have a plan. There's no good just putting one irrigator in and finding that you might have put the wrong one in, it doesn't fit the rest of your farm if you want to put more. So you have to go through that. If you're planning on putting more than one in, a bit of an overall plan of your farm, but you have to then go into it very thoroughly on how it all fits and how it's all going to drain. Well, yeah, you have to be in there amongst it, there's no question. And if you're not going to be amongst it and do that, well, yeah, you might have something you wish you never owned.
There are several aspects of water supply to consider when planning for a centre pivot or lateral move. A secure water supply is required for best results from these systems. Therefore, you need to consider the total on-farm water supply, its seasonal availability and reliability.
Well, we have an underground bore which we had a 225 megalitre allocation. Well, that's now reduced to 50%, so we're back to 110 or 12 megalitres. And we also have a ring tank which is capable of holding 750 megalitres. At the moment it's full, which is great, but it's spent a lot of years being empty. So our main water supply is underground, which is allocated water.
Water quality not only affects crop development and soil properties, but also affects filtration requirements and potential corrosion issues, which can shorten the lifespan of the machine. The source of water affects cost, the quantity of water and its reliability, and water quality. Single or multiple water sources could be used, including groundwater, surface water and effluent from either agricultural, industrial, city or mining operations. When using effluent, special attention should be paid to water quality. The variable cost of water is usually made up of a licence fee and pumping cost, which is related to the water source. The cost of water affects the viability of investing in an overhead system. It can also affect the size of system components, in particular pipe diameter. Finally, available flow rate. This will determine the size of the machine and its design. It will affect how much water can be applied per unit of land and per unit of time. It will also determine the maximum irrigable area for the machine.
Yeah, well, we just water harvest it from the Warrego River, and so far it's been a pretty reliable river. Yeah, there's only 2 irrigators on this river, so it's not over-allocated, and the quality of the water is excellent, so we're fairly fortunate there.
We've got a multiplicity of water supplies. Our first one is our groundwater. We've got about 330 megs allocation of groundwater. We've got a weir in Dalrymple Creek with a yield of, or an allocation of about 800 megs and a yield of well over 1500 megs. And then we've also got an off-stream storage of in excess of 1,000 megs that is filled by overland flow and water harvesting.
The second planning consideration is irrigable area. This is the area you would like to irrigate with the system. For this, you need to consider the available area, which will determine the length, size and capacity of the machine required.
We range from 35 acres to 175 acres and in various stages, and we've got full circle and part circle machines. And as we've got more confidence in the machines, we've got more confidence in where we'll put them and you know, how we'll use them.
We've got 1.6 kilometres to the middle road and then another 1.6 kilometres each side of the middle road, and that works all right. I think you could probably go to 2 kilometres, but yeah, that works well. And while I didn't like the idea of the middle road to start with, as practicalities turn out, like for module pads and servicing and getting around the farm, it's pretty good.
Shape and layout, which will determine the type of machine selected. Centre pivots are more appropriate for square-shaped fields, while lateral moves work best for rectangular fields. Topography, which will determine if special components, like pressure regulators, will be needed to maintain pressure uniformity along the length of the machine. It will also affect the potential for runoff and drainage issues.
Land size and the amount of water are very often two areas that we struggle to obtain the best information on. I'm always very keen to request a properly surveyed, a proper survey is done of the block so that we know exactly what we are dealing with.
Soil characteristics to think about include the infiltration rate and water holding capacity, which will determine water application rates and irrigation scheduling. It is also important to identify if issues like surface crusting, compaction, or high sodium content are likely to affect infiltration rate, so that corrective actions can be implemented. It is also important to know how many different soil types will be covered by one machine, which could affect the design and management of the system.
We have two types, self-mulching black soil and then some loamy red soil comes in on one side of those pivots and then one straight out red soil. We do find a little bit of issues, especially in summer, with the red soil drying out quicker, which may require an extra water in that spot. Yeah.
No, I have pretty much the soil types. There's two soil types. It's sort of a on the lower part of the field, in the low elevation area, it's sort of a heavy black clay soil, and then you know, as it gets up toward the tower, it's more of a duplex type soil. So it's a lighter soil. So it's a bit of a challenge, but yeah, again, it's been managed well.
Location of the farm will determine if the climate is hot, warm or cold. It will also affect the quantity and distribution of rainfall and evaporative demand, which will affect irrigation requirements. Irrigation requirements will have a big impact on the required system capacity and the cost of the machine. The location of the field within the farm, especially with relation to the water supply, will also affect the size and layout of infrastructure like water supply channels, pipelines and pumping stations, which can significantly affect cost. Another main point to keep in mind when planning a system is the system capacity. This is the depth of water the system is capable of applying per unit time. It is expressed in terms of a depth of water, in millimetres or inches, applied during a 24-hour period. For example, 12 millimetres per day. The system capacity should be determined for each individual system. When determining the system capacity, the objective is usually to meet the peak water requirement of the crop, eliminating runoff and minimising initial capital investment and operating cost. Usually, increasing system capacity will increase the initial capital cost, but will decrease the operating cost. Higher system capacity will minimise the risk of potential crop stress and yield reduction, and will provide more management flexibility. Therefore, selecting the system capacity is a very critical decision when purchasing a new system, considering that once the system is installed, it could become impractical to increase system capacity. When considering system capacity, you need to distinguish between design system capacity and operating system capacity. The design system capacity is the capacity of the system to deliver a given depth of water, assuming that the system will operate continuously at 24 hours a day and 7 days a week. This, of course, is almost impossible to achieve in practice. The operating system capacity allows for system downtime. It is important to allow downtime because the system will inevitably need repair and maintenance at some point. The number of hours or the percent of operating time considered adequate is something that needs to be determined in consultation between the grower and the designer.
I'd like to think that there's increasing awareness of the distinction between design system capacity and operating system capacity. When they purchased their machines, all the talk was in capacity. There was never this distinction made between the two. So it's probably the source of the shortcomings of quite a few machines in that they have ordered and received a machine that has a system capacity of, let's give an example of 12 millimetres, a minimum capacity they are required to grow cotton crop in a particular environment. They haven't taken into account the fact that the machine is not going to be operating 24 hours a day, 7 days a week when this peak demand is required. So as soon as there's one little glitch in that whole system, then they're going to start falling behind in their ability to deliver the amount of water that the crop is using.
The adequate operating system capacity depends on the amount of time allowed for system downtime, which will depend on the level of risk the grower is willing to take, the peak crop water requirement, which depends on the crop type and the prevailing weather conditions at the site, and the irrigation efficiency of the system, which is the percent of water applied that actually stays in the maximum crop root zone and is not lost by runoff, deep drainage or evaporation.
These here at peak, I think we're on 11 mils per day.
Okay.
That's what we're on. Yeah.
So that's the design capacity of the machines.
Capacity of the machine, yeah.
Right.
Yeah.
Okay.
Yeah, yeah. And that was basically what we worked around. 12 would have been nice. 10 would have been cheaper, but 11 is where we ended up targeting around that 11 somewhere in there, around that mark.
Centre pivot and lateral move systems require energy for pumping water to provide enough pressure to achieve an adequate application uniformity and moving the system across the field. The cost of pumping water is the main cost of operating these machines. Therefore, when designing a new system, it is important to match the flow rate and pressure requirements of the machine to those of the pumping system. It is also important to make sure that the pumping system is operating at a high efficiency. It could pay, in the long run, to evaluate the efficiency of the pumping system and make changes if needed.
It is something we discuss. You'll find very little differences in the if you were to break out the actual operating cost on a centre pivot between the various brands. Where the significant cost comes into it is actually in pressurised water. So if we're delivering pressurised water to a centre point with a pump and main line, that's where there can be significant differences in systems that I've seen designed, because you can save an awful lot of money by going for a smaller pipe and a smaller pump, but with a bigger engine, because the cost differential going from one size engine to a slightly bigger engine is not that great, as opposed to going to a bigger pipe for the entire distance. So you'll always end up with a very cheap quote, but it'll cost you a lot more money at the end of your operating year. So it's something we try to illustrate to the farmer that yes, the system may be bigger, but your operating costs are going to be less on a yearly basis. So by year 5, you're actually going to start putting money back into your pocket as opposed to going with a smaller mainline, for example.
Since these systems are designed to be able to apply water almost continuously, in addition to water, a reliable source of energy is required. Sources of energy could be diesel, electricity, diesel and gas, or gas. In the case of electricity, this can be supplied either by a commercial supplier or a generator. When considering a new installation, the cost of bringing electricity to the site needs to be considered and weighed against the investment and operating cost of using a different energy source.
When we initially designed the pivot, we did look into using electricity to run our pump. That became too dear of an issue to supply a 200 metre mainline and transformer was in the vicinity of $80,000 to $90,000. So we then decided to put in a diesel powered system, and as we normally did previously, we had a larger engine than required, so that would give us efficiencies. And the engine we have down here, it's a John Deere, which is air-to-air intercooled, and we are getting really good efficiencies of fuel because we've done that.
When using electricity, it is important to consider the type of electrical supply available. Options are 480 volts, 3-phase power supply, or 230 volts, single-phase power supply. Most systems are designed to use 3-phase power, but there are options for using single-phase electricity as well, although with some inherent limitations.
What we have one pumping system for each irrigator. We started the first year with one pumping system for 2 irrigators, and it didn't really work very successfully, so we've now gone to one pumping system per irrigator, and they're either diesel or electric. We have both. Both seem to work quite efficiently. Yeah.
One of the advantages of these irrigation systems is that other agricultural inputs can be injected into the water. The application of fertilisers injected into irrigation water is referred to as fertigation. Nitrogen is the most commonly applied nutrient using fertigation.
We put urea out through our systems quite regularly, and quite simply we just use a poly tank, dissolve the urea in the water and regulate it down to the suction line. Only issues we ever had was, because we use seed, like wheat seed or something, in getting mixed up with the fertiliser, will block up pipes. But apart from that, it works very, very cheaply and very accessibly.
If fertigation is to be applied with the system, additional equipment is needed. The minimum equipment required includes a tank to store the fertiliser to be injected, an injection pump or Venturi device to inject the fertiliser, and a backflow control valve to avoid polluting the water source. Also, you should be aware that fertigation could lead to corrosion problems. Therefore, a system with polyline pipes is an option, or care should be taken to provide adequate flushing to wash away all fertiliser from the pipeline. Pesticides have also been applied by these systems, a process termed chemigation. Only pesticides registered for chemigation should be applied through these systems. Other substances like manure sludge can also be applied. When applying products through the irrigation system, it is important to be aware of and follow all health, safety and legal requirements.
With the fertigation, it is a good way to get maximum effect from your nutrients. However, you do need to have a bit of an understanding of what sort of quantities might be applied at any one time through the crop, and also you need to consider real wet weather conditions, which has been a problem this recently with the floods and things where we've already got waterlogged crops and you still want to be able to fertigate. So the fertigation system needs to be designed to apply the quantity that you want to apply with the minimum amount of water. As in terms of the machine build, I would probably always lean towards a polyline machine if you know you're going to be doing all your fertigation through the machine. However, if with good management it's not necessary with having pre and post flushing of the system. And the post flushing is just simply working out how long you've got to run the water through the system to clear all your nutrients, because the last thing you need is nutrients sitting in the pipe for any time. All centre pivots and lateral moves do self-drain. However, the deposits can sit around where those drain holes are, and that's generally the area where you'll get problems because there's a lot more welded gussets and things around on the end parts of the spans.
Weather events can damage or decrease the performance of centre pivots and lateral moves. The events that are most damaging include strong winds, cyclones, tornadoes and lightning strike. Flood and fire can also be damaging. Where practical, preventative measures should be put in place. It is also advisable to obtain insurance to cover potential damage.
Fire and storm. I mean, these machines don't stand up to a big windstorm. They do go down. Normally it's the smaller pipe will go down first, but I mean they can act like a corkscrew and take a whole machine down. We've had 3 machines in the last 15 years, I suppose, that have been taken down in very severe thunderstorms. And also stubble fires. I mean, if you get a hot stubble fire under there and you lose the temper in the steel, you need to be replaced. They're reasonably cheap to insure. Yeah, look, I just think it should be part of the annual cost of owning one of these machines. I would always recommend people insure them.
We have insured it, not for its full value, but sufficiently to cover what I would class as being able to repair a machine if it got blown over. Of late, with the flood events, there's been quite a lot of machines that have been underwater in this area, and I know the electric-driven machines have taken a fair bit of maintenance to restore them after being underwater, and there's a few machines have actually been toppled over underwater. If you get a nasty mini tornado or something through, it can blow a machine over. I tend to try and leave mine parked in a direction away from where we would normally get nasty storms, but that's probably no guarantee either. But I think it probably is important to insure the machine to a certain amount for that unexpected event.
We have got these insured for storm damage, probably fire as well. You think why fire, but I mean quite a few have been burnt where a paddock, say a wheat paddock's been caught alight or whatever, but we do have them insured. They do tend to go over. I was just thinking this, I know some of the people with the linear moves, they tend to put concrete blocks and they tie them down, but I mean, how do you know when you're going to get a storm? Probably one thing you might consider would be filling the tyres with water or something like that. But usually if you're going to get that storm of that intensity, it's not going to make much difference. But we did lose one recently, or lost a couple of sections, collapsed, and that was due to high wind. It's the direction it comes from and where your machine is. I would think that if maybe if you had it full of water, it might hold. If you didn't, if you had it empty, it might go over. So,
agriculture is a business, and when considering the purchase of one of these machines, you must consider whether or not it will contribute to increased profitability of the farming operation. You need to consider the cost of the machine, including both the initial capital cost and the long-term operating cost, changes in labour, water, fertiliser or energy costs, changes in revenue resulting from changes in yield, quality, area of production, intensification with more frequent cropping, or the ability to produce higher value crops. The repayment period, how long it will take for the machine to pay for itself, and the longevity of the machine, or how long you expect the system to last. When choosing a machine brand and supplier, you need to consider the backup support service available. These machines should have a useful life of at least 20 years. There are several brands and suppliers selling these machines. It is important to choose a supplier that is able to provide long-term support through adequate information, service and spare parts. Ideally, a local supplier will be able to meet these needs. Before choosing a supplier, you need to inquire about the long-term support they offer. It would be advisable to also speak to some of their customers who have purchased machines and are able to comment on the support they have received. Obtaining quotes from several suppliers and discussions with them and their customers is critical for making the right choice. When seeking quotes from suppliers, it is advisable to set minimum specifications for the system required. This enables the supplier to properly design a system that meets your needs. It helps ensure that you obtain comparable quotes from different suppliers. The minimum specifications should include system length, system capacity, type of machine, crops to be irrigated, type of sprinkler package, drop spacing, fertigation equipment, level of automation needed, type of power supply to be used, labour availability and their skill. When evaluating different quotes, it is possible to seek advice from an independent consultant who can review the proposed designs and make sure they meet the minimum specifications you have drawn up. The independent consultant can also suggest which of the proposed systems provides the best value for money. After the system has been installed and commissioned, it is important to check that it meets its specifications. You should consider conducting or commissioning an evaluation of the system performance at this early stage. Good planning processes and consideration of each of these points will lead to a successful investment in your centre pivot and lateral move.